Okay, guys, welcome to week 11 of AMC. So today we're going to be going over some AMC problems involving circle geometry. And then so we'll spend probably half the meeting working on those questions. We have 5 of them. And then we'll spend the other half doing a puzzle. So yeah, let's get started. Do all of you guys know like basic circle geometry and stuff? Like the area, the circumference, the surface area. I don't know. Are you guys all familiar with this stuff? Oh, chat. Yes. All right. So yeah, we'll just get started solving some of these questions. So these are in AMC 8, and most of these questions are some of the harder ones. So we have problem like they're all above problem 15. So let's get started with the first one. All right, so Jerry cuts a wedge from a 6 centimeter cylinder of Bologna as shown by the dashed curve. Which answer choice is closest to the volume of his wedge in cubic centimeters? Alrighty, so you guys have any idea how we're going to solve this one? We need to solve for the volume of the wedge. Anyone? So remember, let's try to think about what we're trying to solve here. If we're just cutting a wedge, this is going from corner to corner or side to side of the cylinder. Multiply by 8 and 6. What do you mean? Like to find the total volume of this? Yeah, we're on the right track. So we need to solve for this first. So let's first find out what the total volume for this is, right? So to do that, we're going to get the area of the circle here, and then we'll multiply it by the height, which is 6. So to get the area, anyone know how to do that?
Anyone? So does anyone know how to get the area of a circle? Or not the area, but
If you guys want me to explain this, I can. I'm not really sure what everyone's like math level is at. So if you guys want me to,
have you guys learned about circumference and stuff? Any of you guys?
please explain. All right, so to get the area of this circle here, right? So this is a circle. You learned circumference in 6. I don't remember. I'm not sure. But I'll explain it real quick. It's not very hard. All right, so this circle is a diameter of 8, right? So in going across, it's 8 centimeters. So that means our radius, which is half the diameter here, is 4. So to find the area of this circle, we want to get the radius squared times pi. That'll give us the area for this. So this would be 4 squared times pi. And you can just approximate pi as 3.14. Right, so the area of this using this would be 4 squared, so it'd be 16 times pi. So that's around 50 point, I'll just round 50.3. So we're getting around 50.3 centimeters squared. All right, now, so we know the area of this circle here. So how do you find the volume? This is just like most other 3D shapes. Yeah, okay, so we know the area of this, so we can just multiply the height, right? So we can just multiply what we got here by 6. So I'm just going to approximate. So I'll just say like 50 times, so I'll just say around like 300, right? So remember, it just wants us to, which answer choice is closest. So for this, you can usually just estimate. So that's around 300 centimeters cubed for the total volume. We want to find the wedge, right? So how much would the wedge be? Like if we know the whole volume is 300. You guys have any idea? Anyone?
Anyone?
You can use the chat for all your answers if you want.
Remember that think about how much this area would actually be if it's cut like this. Like, would it be half? Would it be 3/4? Like, think carefully about the shape and how it's not so different from being cut in half. Anyone?
All right, yeah, so actually if we cut the wedge, like if we cut the cylinder like this in a wedge, it's pretty much, if we take the cross section of the side, right? If we're looking at it from the side here, what you're just doing is cutting it like this, right? So that's the cross section or the side view of the wedge. So really what we're doing here is we're just getting half the volume, right? So half of 300, that'd be 150. And the closest answer to that would be 151. Does everyone get that?
Yes or no? Hello?
We get this? If there's anything you want me to explain again, you just type in the chat, or no questions?
No questions.
All right, let's move on. So next question here is going over pretty much all the stuff for the circles. So Amanda draws 5 circles with radii 1, 2, 3, 4, and 5. And then for each circle, she plots the points C and A, where C is the circumference and A is its area. So we already went over how to find area. Does everyone know how to find the circumference of a circle? So circumference would just be the distance around the circle. You guys know all know how to find that? I'll just explain it in case. All right, the circumference is actually super easy. So to find the circumference of any circle, you just want to get the diameter, so the distance across here, and we want to multiply it by pi. So the circumference will be diameter times pi, or 2r pi. So 2 times the radius times pi. So the C will always be equal to this, and the area will be equal to radius squared times pi. And we're doing this for circles radii 1, 2, 3, 4, and 5. There's no specific values on the graphs here, as you see, so we can just pretty much find a rough estimate for all of these. All right, so anyone want to give a shot? We're going to go just approximate the rough circumference and area for all these circles. And then we'll be able to see which one matches up or which graph is the closest.
Anyone?
So make a little table here. This graph is just showing the relationship between the circumference of the area of a circle as the radius increases. So I'll make a little table over here on the side.
A hint. If the radius is steadily increasing 1, 2, 3, 4, and 5, would we be more likely to see an upwards trend or downwards trend? And would it more likely be a line or a curve? Think about it.
All right, we'll just go ahead then. We'll go ahead and start with radius 1. So what would the circumference be if we do radius 1? Remember, we're going to use the top one here for circumference. Anyone? All right, I'll go ahead and solve. So the radius is 1 here. So the circumference will be 2 times the radius times pi. So that'll just be 2 pi. And the area will just be the radius squared times pi. So the area for this is just pi. And because there's no specific values on the graph here, we just need to find the relationship between them. So we don't really actually need to solve for the whole number. We can just use pi as a variable here. All right, for radius 2, it's pretty much the same thing. Radius 3. Anyone know what it is for radius 4? We have a circle with radius of 4. Anyone? All right. So 4, same thing, plug it in. Get that 8 pi. We're 16 pi. 5 is just 10 pi. All right, so now with the values that we've gotten here, which graph do you think matches up the closest? Remember, they're all being multiplied by pi. So really, you can just look at the numbers here to get the relationship. You don't need exact values for this. So which graph do you think will match it the closest for plotting these points here? All right, well, we can work through each one. So we'll go take a look at each graph here. Let me switch to a different color. All right, so let's just start with this one here for plotting this. So we'll just say 2 and 1. So 2 pi and pi. So that'd be, let's say this is here. We're starting off. That's the smallest value. So you can assume it's the closest here. We go to 4, and this is also 4. So far, it's looking good, right? It's increasing. We go to 6 in the circumference. The A area also increases by a little bit more this time. That makes sense. We go to 8 pi here. So that's this one here. This time it's increased to 16. So that's a larger increase here. And then 10 pi and 25 pi. All right, so that looks pretty good, right? You guys agree?
Any questions on why it would be curving up or anything else about this that you find confusing?
Yeah, so far A looks pretty good, right? All the values seem to match up. They're all increasing the right way. So if we're not sure, we can still check some of the other answers, right? For example, D here, it's also pretty similar to A, right? As our C increases, the A also increases, right? But the difference between A and D here, didn't mean to draw that. The difference is as A here, as C increases, as the circumference increases, the A increases exponentially. So it's increasing more each time, as you can see here, right? In our numbers that we've gotten here for the values, it's increasing not linearly. And you can see that here in A. So the spacing between here versus here, it's a lot more, right? Versus in D, it looks like the spacing is all pretty similar. So that's why the correct answer here would be A. Did everyone get that?
Everyone get, could anyone please respond? Anyone? Yes or no? Yes, okay.
Right, cool. We'll move on to the next one. So now we've got circumference and area down. So now we're going to use that. So two circles that share the same center have radii 10 meters and 20 meters. So I'll go label that here. So the inside here is 10, and the bigger radius here, that's 20. Aardvarks, that's an animal, just runs around the path shown. So these arrows here, starting at A and ending at K. So how many meters does the aardvark run? So how do we go around solving this, right? We need to follow the arrows. Anyone have an idea of how we can go about solving this?
Anyone? Lloyd, how about you try to solve this one? Hello?
Need some help with the question, or yeah, just give it a try. You know, what's your idea of like how we can solve this question with what we've learned earlier?
It looks complicated, but it's not too difficult once you sort of get the trick, per se.
So yeah, all we need to do is really just simplify here, right? So what are we really doing? So what lengths do we already know it's traveling? I'll go ahead and erase this.
First of all, to make things simpler, instead of thinking of it as an interconnected circle, think of it as two separate circles, one big one and one small one.
So we'll split up each of these arrows into different lengths, right? So obviously we don't know what these curved ones are yet. So let's focus the straight lines. What do we know here? We know that the inside radius has length 10. Here, I'll zoom in a little bit. Inside has length 10. Sorry, not a 6. And we know that this whole thing is 20, so that we also can find that the outside bit here, that's also 10. So with this, we can already find all the straight arrows, right? So this first arrow here, that's 10. Plus going up here, that's 20. That's the diameter of the smaller circle. And the going back out here to K, that's another 10.
Now, the seemingly tricky part is finding the curved, but all you have to do is find the circumference and then divide it by 4. So to find the circumference, it is going to be 2 pi r, and then to r, of course, is the radius, right? So now for the big one, first let's go off with the big one. From A to the other corner, 2 pi r would be 20 times 2, which would be 40 pi. However, we divide it, so it becomes 10 pi squared, or 10 pi, yeah.
So 40 pi is the entire circumference, right? But
And
we only
you
want
have to
find
make
this
sure to
one
divide it
quarter.
by 4.
So we want to divide by 4. So this distance here that's running is 10 pi.
Yep. And I'm sure you can see where we're going here. So why don't you try to solve the smaller circle? It's exactly the same methods as we've implemented, only in smaller in scale. So how about you try it out, Lloyd? Lloyd?
Anyone have a guess? Joyce?
Anyone else? Yeah.
Claire, you guys have an idea? Nope. All right, so let's think about these arrows here, right? We have where these arrows, they're on the same circle. So these two curved ones here, I'll use a different color so it's easier to see. These two curved arrows here are both in the same circle. So this one up here, that's going 1/4 of the circle or the circumference. The bottom one is another quarter, right? So this together adds up to half the circumference. So what's half the circumference of this circle here? We just need to find half. So we need to find from here going around to here. We know that the radius is 10.
And we can implement the 2 pi r, but instead of dividing by 4 this time, divided by half. So I'd really appreciate it if one of you could finish up the equation we've set up for you.
All right, so I'll just go ahead and do this. So we need to find, let's start off finding the whole circumference. That's 2 pi r. So in this case, r is 10. So the whole circumference here is 20 pi. But then again, we only want to find half of it. So we can divide that by 2 to get 10 pi. So the inside part is 10 pi. So that means each of these is 5 pi here. So our total, so I'll just write total equals all of the red bits here, which we already found, plus 10 pi from the small circle bits, and then plus 10 pi from the quarter of the big circle. So adding all this up, what do we get? So 10 plus 20 plus 10, that's 40. Now let's change colors. That's 40, and then plus 20 pi. So our answer for this one is E. All right, does everyone get that? Any questions?
Any questions? Yeah.
Blair, what part are you confused about? I can re-explain it. You want me to go over the whole thing again real quick? Or is there just a specific part? Oh, pi is just the, okay, you don't have to worry about pi. Pi is just a number, okay? So for now, we're using pi as 3.14. So pi for now, it's just a number. It's just, instead of writing 3.14, we're just writing the little weird symbol.
Think of it as like a shorthand, nothing too complicated, just like a substitution the way, like, for example, even addition is like pi in the sense that we use it as a shorthand instead of always saying adding together. Like, don't just think of it as like something scary or advanced. It's really just simple. It's more for convenience than anything else.
Yeah, so pi is actually, the decimal's going forever. So it's not a pattern or anything, but to keep things simple, we always use 3.14 as pi, or most of the time. And then it's really just used to solve for circles. So you can use it to find the circumference in the area. So it's just a number. You don't have to worry too much about it. And for most of these questions, when actually using it, it's just acting as like X or something, because the answers, they include pi. So you don't actually have to solve the whole thing. Does that make some sense? And don't worry, you'll learn it soon. What grade are you? Yeah, I think 6th or 7th grade, you guys will get around to that.
Yeah, it's not too advanced of a concept. All we're doing is giving you a head start for the future.
All right, cool. Move on to the next one. How are we doing on time? All right, 7:27. All right, so this one is a little bit harder. This is problem 23. So let's go ahead and read the question. Angle ABC, so this is this angle here, of triangle ABC is a right angle. The sides of triangle ABC are the diameters of semicircles as shown. So the area of the semicircle on AB equals 8 pi. So this semicircle here is area of 8 pi. I'll zoom in. The arc of the semicircle on AC has length 8.5 pi. So this time it's the arc, not the area. Oh, it's my handwriting. what is the radius of the semicircle on BC? So what are we looking for? We're looking for the radius of the semicircle in BC. So that's pretty much this part. Any of these is the radius. All right, so it actually seems, I guess, pretty intimidating, but it's not that bad. Let's break down the question. So how can we find the radius of this? So we need to work backwards, right? So the radius here, we know this is a semicircle going across this whole side. So the radius is just half of the side length, right? The side length BC is the diameter of the semicircle. So what we're looking for is half of BC. So 1/2 length of BC.
Yeah, an
And
easier
how
way
can we
to,
get that? We know the arc length of the circle on AC, right? And we know the area of the semicircle on AB. So we can probably use those to find the side lengths of AC and AB. And then from there, we can use the Pythagorean theorem to get BC and then solve for this. So let's break it down. Let's start off with finding AB. So how can we find the length of AB? Anyone have an idea? I'll write down the area and circumference formulas again in case you guys need it. So area is pi times the radius squared. Circumference is 2 times r times pi. All right, anyone have an idea? Remember, we're working for finding AB first. So,
yep. Just split it up into little parts and seemingly big problems become much, much easier. Blair, you want to try this one out? You haven't talked in a while. Or can you turn your mic on? If that could be okay.
you can use the chat too, that's fine.
Yeah, I guess chat.
Yeah, so any idea? Anyone? Joyce, Loy, you guys got any ideas for this? We're using the same concepts as we are earlier, but this time we're working backwards. So instead of looking for the area using the radius or the diameter, we're looking for the diameter or radius using the area that's given to us. All right, so to make this a little bit simpler, that's what's confusing you guys. All right, it's okay, I'll go through this one. So first of all, let's make this a little bit simpler. Let's get the full area of the circle first. So what's the full area of this circle? We know that the area of the semicircle is 8 pi. So what's the full area? All right, so semicircle is half the area, right? So the area of this full circle will be 16 pi. And then so remember, let's use our equation here. So 16 pi equals pi times the radius squared. So remember, we're looking for the radius here. So now this is just algebra. So have you guys learned like basic algebra, like solving for x? Or I can just go over that real quick. Yeah, okay, so I'll go over solving for the radius here. So first of all, remember, don't worry too much about pi. If pi seems scary, you can just replace it with a different variable for now. So I can just write this as like 16x equals x times the radius squared. And then both sides are being multiplied by x, right? So this is 16 times x, and this is x times radius squared. So to get rid of the x, we can just divide both sides by it. Right, 16x divided by x, these two will cancel out. So we'll just be left with 16 on that side, and on the right side, radius squared. Does that make sense? If it doesn't make sense, just tell me in the chat. I'll go ahead and explain it in a different way or in more detail.
All right then.
Okay, so I'll assume you guys sort of know this. So now we got 16 equals the radius squared, right? So now we can just solve for r. So you just get the square root of 16. Remember, 4 times 4 is 16, so the square root of 16 would be 4. So now we've solved for this. We've gotten that the radius of this circle here, the radius equals 4. And since the radius here is half of that, AB, we now know is 8. Yeah, do you guys see the explanation in the chat? That's a much better explanation than what I gave. Remember, we're setting both these are equal to each other, right? That's what we have the equal sign in the middles. So you divide both sides by the same thing. We're both dividing by x here, or pi. We end up with still the same. They're both equal to each other. Does that make sense? Guess we can do like a basic algebra week next week. It is 7:35, so we're gonna hurry up and finish this question. I don't know if we'll have time to finish all the questions today because we still want to get to the puzzle.
Yep.
Are you guys all get this? So yeah, we've already solved for AB. We know that AB is 8. So now let's move on to AC. I'm gonna solve this using a pretty similar thought process, but this time instead of giving us the area, they gave us the length of the arc. So when we cut up a circle, if we're just getting like a piece of the circle, right? We call this an arc. So we're just looking for the length of this. So we can again do some algebra. We know that 8.5 pi is equal to 8.5 pi is equal to half of the total circumference, right? So the total circumference for this would be 17 pi. And that's equal to this equation here, 2 times the radius or diameter times pi. And again, AFK, because AFKing the whole meeting. That would be really good. But yeah, so just like earlier, remember both sides are being multiplied by pi. 17 is being multiplied by pi, and 2 times the radius is being multiplied by pi. So we just divide that to get rid of it. So now we get 17 is equal to 2r. So we get r is equal to. I'm going over through the whole process of using the equation or the formula for this. Once you guys get a better understanding of this, you'll just be able to tell, like, you don't have to go through the full thing. So now that we got the radius of this is 8.5, what's the side length of AC? We know the radius of AC, or this bit here in green, that is 8.5. So what is the whole length of AC? I remember it's just the radius, so we're getting the whole diameter, so you can just multiply that by 2. So now we get AC equals, I'll write that down here, AC equals 17. All right, now we know enough to pretty much solve for this, right? We already know AB equals 8, AC equals 17. So we know this is a right triangle. We have 2 sides of that right triangle. So now we can use the Pythagorean theorem to finish off this question. You guys still remember that? We went over this a few weeks ago. All right, I'll go over it real quick. Running low on time. We're going to get to that puzzle. So when you have a right triangle, I'll draw another one down here. Oh, that doesn't look like a right triangle. Pretend it is. So this is, we'll label the sides A, B, and C. So A squared plus b squared will always be equal to c squared. And this only applies to right triangles. So we already know c in this case, we know c is equal to 17. So we know 17 squared equal to, we know this side AB, which is 8. 8 squared plus b squared, right? So now we can just solve for b. So 17 squared, we can just move the 8 over, right? We can subtract both sides by 8 squared for the algebra here. So that'll give us 17 squared minus 8 squared equals b squared. And remember, we just set the bottom side length as b for this. We just set it equal to b here. So a squared minus b squared. Let's use 17 plus 8. 17 minus 8. Sorry, am I going a little bit too fast? Any parts that you don't understand, I can go over again. Don't worry about that. The goal here is to make sure you guys can sort of understand these concepts. You don't have to fully understand it because it's probably a lot ahead of your grade level. This will give you a little sneak peek in harder math. You guys good? All right, so continue. What I'm using here is a little shortcut for solving these big numbers. But yeah, so 17 plus 8 minus 8. So it's 225. Okay, we're good. So we got b squared. So I was just using a calculator there to solve for this. It's a little faster than here. You guys don't have to understand all the algebra for this completely, but what we're getting here is that we solve for this using the Pythagorean theorem. We got b squared equals 225. And to get the square root of that, that's 15. Because 15 times 15 equals 225. So now we're almost done. We know BC. This question is a mix of algebra and geometry. Yeah, so the main concepts are all geometry, but we're using algebra to find all the side lengths. It's okay. You'll get this sooner in middle school.
Yeah,
you
the
get
purpose
more
of the math club halfly is to sort of get you familiarized so that you can kind of, know it a bit better than your peers.
Yeah, depending on which math class you guys are in, you should cover all this by 8th grade. If you're in a little bit faster class, you'll get through this by 7th or 6th grade. But yeah, all right, so we got BC equals 15. Let me clean up a little bit. Down here is getting messy. And so what's half of that? That's 7.5. So we got our answer here. The radius, or half of this, BC, is 7.5. Hey, no problem. Thank you for coming to today's meeting. If you want to check out this Jamboard later, the link will be on there. If you have any questions about it, you can just ping one of us on the server. All right, bye. All right, so we solved for this one. We got B. So we're really running out of time. Hambo will continue finishing these questions with you guys. So there's only one more. He'll go over this with you guys next week. But since we're running low on time, let's get to the puzzle. All right, here it is. So today's puzzle is lots of plots. This one is a slightly harder puzzle, I guess. But it's very simple. So the whole goal of the puzzle is you want to fill up all of the dirt using the carrots. So it's pretty much just like dominoes. Right, so you have these vertical ones, you have the horizontal ones. And the challenge is to be able to fill up all of the dirt. So let's go over, do something simple first. So we'll start off with this. All right, your guys' turn now to solve this. So anyone have an idea how we're gonna go through this one? Joyce, all right. One there. Yeah, got it. So that was pretty easy, right? So this one's pretty basic, but you guys all get the idea now, right? So we're gonna move on to some different questions. So we're first gonna try to find a pattern for which kinds of widths and heights are impossible, because there are a few of them that are impossible. Like if we try to solve a 5x5, you can try solving this. You'll find that's impossible. So like we just fill out the grid here. Oh, we just fill out the grid. We'll find that there's one left. And this is true no matter how we do this, right? Because the area of this, right, is 25 of these little dirt plots. But using the domino pieces that we have, they're only in multiples of 2. So we can only ever get a 24 on here. We can only fit 24. And so that's why we can never fill up this. Does that make sense, guys? So let's see if we can fill this one out too. So remember I told you guys that. Oh, what, you think we can fill the 3x5? Oh, Joyce says no. Yeah, why is that? Aloy also thinks no. Yeah, so why do you guys think that? If you just try and solve this. Yeah, 15 is an odd number, right? So the total area of this is 15, and with the pieces that we have here, there will always be one left over. Yeah, great, so you guys got the math on this. Now let's have some fun. I don't think we need a password. So we use the blocking square, right? So if I do put one of these squares on here, right, what's the area of the dirt now? This area of the dirt now is 24, right? So if I put a little block here, you guys will be able to solve this. So do you think you'll be able to solve it no matter where I put this little rock on the field? Yes? All right, let's give it a try. So let's go. I'll put this somewhere. So we already know the corner can be solved, right? So let's say we put it right here. How do you guys think we can go about filling all this out? Nice. God, that was really fast. Yeah, nice. So you guys got it, right? Okay, reset. I don't know why it's not letting me reset. I'll just erase all of it. All right, what about if I put the rock here? You think this is still doable? Yeah, Lloyd, you can also use the whiteboard if you want to put suggestions for where to put all these. Yeah, Joyce, you got it. So it's pretty much for as long as the area checks out, right? As long as the math checks out, at least when using these 1x2 caret little pieces, we can fill out any plot as long as the area is even, because we can make that area using these pieces. All right, so now we can do something a little bit more interesting. So we got these 1x3 pieces now. So now we got lettuce, yes, or cabbages. Yeah, so do you guys think the rule for which plots can be solved changes when we do this? Yes, right? Because the area of the pieces changes. Instead of area of 2, the area is 3 now. So do you guys think it's possible to fill out the 5x5? Loy, all right, yes. All right, let's see. Oh, we gotta use the rocks, right? Yeah. So if we're just using the cabbage pieces, it's not possible, right? Because if we're using these cabbage pieces, they have area of 3. But the total area of this 5x5 without the rocks is 25. And then so we're multiplying by 3, we can't get a 25. The closest we can get is 24, right? All right, so we got that rule. So let's solve some interesting ones. I'll open up all of the pieces here. So this is pretty much Tetris. We got the L piece, we got the I piece, the T. I don't know what this thing is called. A little squiggly, and the box. So let's just go ahead and solve some interesting puzzles. We'll try our best to not. We'll try our best to not use the rocks. So, yeah, Loy, you can also use the whiteboard if you want to suggest pieces. So yeah, let's get to solving this. See, we can fill this out because here the math gets a lot more complicated, right? For solving which ones are possible. Because not only do you have to account for the area, we have to account for the orientation of these. Loy, you can't use the whiteboard. It should be that everyone can use it. Can you find the whiteboard function? No, it should be on the Zoom, like the bottom. There's like the 3 dots. The more you can click access whiteboard. Can you find it there? The whiteboard should be open for all people right now. Well, if you have any suggestions for where to put it, you can just say it in the chat. We have coordinates on here. Or you can just unmute. That also works. Yeah, so you guys think this is solvable with all these pieces? If we're trying to use every single piece here, it's pretty hard to solve, right? One piece there, and then now we're missing one here, so we're gonna have to use the rock. Yeah, so from here, we're gonna pretty much have to fill the rest out with rocks, right? So if we're trying to use every single piece here, it's a lot harder. And really, you can mathematically solve for whether these are possible or not, but it just gets way more complicated. So let's go back to the basic 2x2 dominoes, and then I'll make some puzzles and we'll see if we can fill them out. Actually, let's switch to dominoes. That's a little bit more interesting. All right, you guys think this is solvable? Can we check mathematically first before we start going off on this? Yes? All right, let's see. So you got the cabbage piece there. Yeah, so this one's not possible, right? So now you find that even if the math checks out for this, right? Because the area of the dirt here is 30 minus 6. So it's 24. And we can technically make that using the cabbages. But now we have to keep in mind the orientation because these are 1x3 blocks. Unlike the 1x2, which you can pretty much fill in anywhere. How are you doing on time? 7:54. All right, I'll make another puzzle. All right, can we try solving this one? Remember, we're using is this corn? Yes, we're using the 4 long pieces. So these are 1x4. Joyce, which piece did you mean by those? Okay, yeah.
Is your screen frozen or am I just seeing this?
Oh, my screen's not frozen. Is my cursor moving right now? Can you see it?
Oh, now I can see it.
Okay. I see this time it was solvable, right? The math checked out. We were able to get the area. And also where I put these rocks here, they left enough space for us to be able to still fill it out because we can use 4 here and the 2 pieces here. All right, so yeah, that's about it for this puzzle. It was just a little simple logic puzzle. I guess there was a bit of math to it. But that's it for this week. We're ending a few minutes early, but that's okay. Today's math was pretty hard with the AMC problems. So if you guys have any questions about this, please feel free to message us on Discord about this. And then Hambo will go over these questions again a little bit, and then he'll finish off the last problem that we didn't do. But yeah, that's it for today. Yeah, thank you guys all for coming. That was I guess the first bit was kind of boring. All right, that's it for
All right,
this.
thank you so much.
Oh yeah, no problem, Joyce. See you next week.
Goodbye.
All right, we did it. We did it. I'm gonna stop
You
recording.
didn't stop recording.
We're done. That's another
Done.
meeting.